snow-fed river. And snow-fed rivers in Southwest North America are the proverbial canaries in the coal mine for hydrologic change associated with rising temperatures, because the rise in temperatures that we have seen has already started to diminish the snowpack in the upper Rio Grande, and that is projected to continue as temperatures continue to rise. So some recent work that I and a student of mine have done, which I might actually have a slide to show you in a few minutes, suggests that the rate of change, that snowpack in the upper Rio Grande over the last 40 years has diminished by 25%. That is over and above the natural variability, which is substantial from year to year associated with precipitation changes. So we are looking at a world in which snow simply disappears at these latitudes, with tremendous projected decreases in snowpack over the course of the 21st century. Those changes in snowpack are projected to change the absolute amount of water flowing down the river as evaporation rates increase and the snow-free season becomes longer. And so we have estimates of projected stream flow change on the order of 20% decrease over the course of the 21st century, and that is the surface water supply for the Rio Grande until we get down to the Conchos. More about that in a moment. So we are looking at potential long-term decreases in surface water supplies as the climate warms up. The other major component of hydrologic change associated with global warming is an increase in precipitation variability. So a more energetic climate system allows for more intense variability of precipitation, which means that even if the overall rate of change of our water supply is trending toward aridity, that we could also have isolated instances of very high precipitation leading to the sorts of flash floods that generate those large arroyos that I drove past on my way south from Albuquerque yesterday. So we have the paradoxical combination of a prospect of less water supply in this part of the world in general, combined with the possibility for more intense short-term flooding. Finally, let me say a few, that's the upper part of the Rio Grande, and I'll say just a few words about what happens farther downriver. The Conchos, which is the other major supplier of water to the Rio Grande, is a rather different hydrologic system because it is not snow-fed. The major supply of water into the Conchos is summer precipitation from the monsoon, as well as some winter precipitation. And there we have a different challenge because the actual effects of projected decline in precipitation become more pronounced. If we look at a map of precipitation, which I wish I could show you, what we would see in the projections is that the major target of climate models for precipitation change in Southwest North America is actually south of the border in northern Mexico, where precipitation is projected to decline very significantly as what we call the Hadley circulation in the atmosphere expands, and essentially the dry zone of the subtropics expands poleward, and that has the effect of leaving northern Mexico drier than it already is. So projected precipitation change in the Conchos leads to a similar projection of stream flow decline, but for somewhat different reasons. Instead of melting snowpack, it's because of an actual decrease in the amount of precipitation flowing into the system. So we add all that up, and one of Greg's concluding slides was a photoshopped road sign that pointed toward doom in one direction and gloom in the other direction, and you have your choice. But that's, I'm just presenting Greg's message, right? So So we have some pretty severe hydrologic challenges over the long term. And with apologies to Greg, I'll then move on to some of my own slides, if I can find them. There we go. So now my presentation, as I was requested to talk about, is more about the natural variability of the system. And this represents the kind of challenge that we face here in this part of the world naturally, right? Even disregarding any sort of forced climate change due to the activities of people. And this is the sort of situation that people and ecosystems in this part of the world have faced for many centuries, since the last ice age. So here are two plots of precipitation on the left and upper Rio Grande stream flow on the right from the Ottawa Gauge up in northern New Mexico. I deliberately put the plot on the left to pay homage to my colleague Greg Garfin, who I thought I'd get to see here, because this is a slide he put together a decade ago for a report that the two of us worked on for the state engineer in New Mexico. And it shows a tree ring reconstruction of precipitation for northern New Mexico, and a similar reconstruction, also based on tree rings for the last 500 years, is shown on the right for the Rio Grande. And the point here is that thanks to rather modern dendrochronological tools, we can now look back at the sort of variability, hydrologic variability that exists in this system going back many centuries, which is a really powerful tool because it tells us what this system is capable of doing to us when the system gets stuck in drought. So that one doesn't work. No, that won't work either. That's a USB drive. Yeah, it's pretty wimpy. There are some whopping big droughts, is really all I wanted to say. And the point is, bigger and longer than we have seen in the instrumental record, and including the drought of the 50s, which is the drought of record for many water supply systems in New Mexico and Texas. We can, and Greg has very helpfully annotated the slide on the left to remind us that in history, really bad things have happened when the system goes dry for a decade or two or three at a time. We have not seen droughts like the 16th century mega drought or the drought that seems to be correlated with the collapse of the Mimbres culture. We've just not seen droughts that long and deep since large-scale European settlement here. So that's the kind of thing that can happen. And we ought to understand that these sorts of events have happened in the past and be prepared for them potentially to happen in the future. We actually have an increased understanding of what makes those go. We think that the system gets stuck in what we call a La Nina phase for years at a time, that steers the winter storm track north and simply dries out the southwest in much the same way that's happened this year, but imagine that happening for a decade or two or three in a row. So with that kind of drought history, I'll return quickly to the point that Greg was trying to make and simply say that what is happening with the climate system now simply makes these natural challenges worse. So here's the slide I mentioned showing a time series of peak snow in the upper Rio Grande headwaters since the late 1950s. And there are snowy years and not so snowy years, lots of up and down variability. But if I simply fit a straight line through that plot, the overall decrease in snowpack is 25% since the late 1950s. And this year's datum will simply pull that line down even farther. one of the things that kind of change makes more difficult for us is that it makes it harder to actually predict how much water will flow down the river based on observations of snowpack. This slide shows in the upper panel the kind of relationship we saw in the 60s and 70s between snowpack and streamflow, and with a simple linear regression, you could make an excellent prediction of snowmelt runoff in the Rio Grande just based on an observation of snowpack at the 1st of April. And so the immediate effect of decreasing snowpack is you start to loosen that relationship, and it makes it harder to use snowpack as a predictor of how much streamflow we'll get, which is something that water managers that are managing reservoirs and looking at surface water use all the time. So that scatter plot on the bottom shows a much looser, less tight relationship between snowpack and streamflow, making it more difficult for us to manage the water resources that we have because we can't use snowpack as such an immediate direct predictor of snowmelt runoff. The importance of precipitation and temperature is increasing as the snow starts to melt. And that brings us to what's happening this winter. We can't stop this presentation without giving you the ultimate gloom and doom picture. We've had a gigantic meteorological ridge pushing storms way up toward the state of Washington this winter that's been stuck there, at least until the last week. So as of February 18th, we were looking at historically poor snowpack conditions across the entire Southwest. So all those purple and red dots across the southwestern states of the U.S. indicate a near absence of snow in the major snow-fed rivers in their headwaters regions. And so on the right is a plot of the upper San Juan, so it's a little bit off across the divide from the Rio Grande. But that black line shows the average progression of snowpack for many years, and the red dot shows where we were on February 18th, which is really bad. Things have gotten a little bit better since I put this slide together, so we've actually gotten some good dumps. One of the students in my class is on the UNM ski team, and she says things are looking better. But it's still, there is essentially zero chance this year that we will obtain anything like close to average snowpack based on historical records, and therefore we should expect far less than some sort of average amount of snowmelt runoff coming down the Rio Grande. I'll skip through this quickly just to show you a couple of things. These are the kinds of operational streamflow forecasts made by the U.S. Natural Resources Conservation Service. And what we see is that in 2017, so each of these forecasts is for the period of April through September, and the NRCS updates them every month starting in January. So each of these box plots is the same forecast for a particular year. We're forecasting the snowmelt runoff season starting in January and then updating the forecast through June. And what we saw last year in 2017 was a really great snowpack that started off such that, if you can see these boxes up here were for well above average stream flow last year, and that's based on a snowpack that was about 50% above normal that we saw last year, leading up to the peak snowpack period. However, what then happened, as you can see, is that the forecast slid back toward normal, and what we ended up with coming down the river was something very close to average flow. That's bad news, because the effect of warmer temperatures and increasing snowmelt on this sort of hydrologic system is that even when we get 150% of snow in February and March, we end up with nothing more than average stream flow coming down the river. That's the effect of climate change on natural variability in the system. Here's the picture for this year, these two boxes here. This forecast will be updated next week, dated today, based on 1st of March snowpack conditions. and it's abysmal. It just doesn't get much lower than this. And so we are looking at a very likely prospect for utterly dismal stream flow coming down into Elephant Butte Reservoir, which is pretty empty to begin with. So this is a bad year for us. So when we think about drought and the Rio Grande, and let me, I had one other slide here that didn't get in here, but let me make one quick comment about the Conchos, which again is a different kind of system, but still is afflicted by drought. However, because the Conchos is a summer rainfall system as opposed to a snowmelt runoff system, and because summer rains are only weakly correlated with winter snowpack in Colorado, that means that the systems operate nearly independently on a year-to-year basis. There's very little correlation between the annual flow in the Conchos and what's coming down in snowmelt runoff on the upper Rio Grande. Much of the time, I suppose that's kind of good news because it typically dismal conditions on the upper Rio Grande like we have this year do not necessarily mean that we'll have deficient flow in the Conchos. However, it also means that when we have these very large-scale mega droughts of the sort that showed up on those initial plots I showed you, that's when we're really stressed. That's when the entire Southwest is just dry. Sometimes that happens for years at a time when drought on the Conchos and drought on the upper Rio Grande line up. We have very little ability to make a forecast of summer rains that feed the Conchos months in advance, so we'll hope for the best. So let me conclude just by saying that drought has been part of life along the Rio Grande for millennia, and anybody that chooses to survive, much less thrive here, needs to manage and plan for that. The ongoing climate change on which we'll blame Greg Garfin for that, is going to make these episodic droughts worse, and we need to know that, and we need to plan for that. We have much, much better tools. We have much greater awareness of the kinds of things that can happen in this system than we had even a decade or two ago. We can look both backward and forward in time and gain guidance about what the system might have in store for us and what we need to be able to manage. The Mimbres probably didn't know what was going to hit them, but we don't have that excuse. We know what has happened in the system, and we would be foolish not to plan for and manage really hard times hydrologically in the Rio Grande Valley. And for 2018, there's still a couple weeks left in the snowpack season, at least in the headwaters of the Rio Grande, so everybody thinks snow. And with that, I will conclude, and I hope we'll have time for questions at some point. And let me apologize again for the problems with the slides.
Do you want to do the questions afterwards? Yeah. At the end, yeah, we'll do Q&A afterwards. Yeah, very good. Okay, our next speaker is Alfredo Granados Olivas. He has a PhD in urban studies from the State University of Nuevo León. He is now with the Universidad Autónoma de Ciudad Juárez, and his professional interests have been in the land use and effect on the environment, urban hydrology, and groundwater studies as well. So with that, Alfredo, please.
Thank you. Well, the actual title of my presentation is Transboundary Aquifer Management at El Paso del Norte. And I put a question in here as Teresa was challenging as, is it possible? And with this, I think I will keep, as a friend, my colleague, Dr. Salmon, because I'm going to be challenging everyone to think about these issues. First, I would like to appreciate the invitation to this important U.S.-Mexico Border Water Summit. Today, as we saw earlier in the morning, we heard some interesting presentations regarding different points of view about border water issues. I'm sure that along the 2 days of work, we will keep learning from excellent presenters and recognized scientists, as well as from agencies from both sides of the border. I look forward on hearing different perspectives related to water management, and especially about transboundary aquifer management at the Paso del Norte. Today, I would like to share with you my points of view regarding the challenging task, managing transboundary groundwater resources with an holistic approach along the Paso del Norte region. And I should emphasize on this definition, to reach a view regarding groundwater resources at the border as a common shared resource. For this purpose, I will try to give some facts and recognize huge challenges we have in front of us, while playing our roles at the academia, at official water agencies, as well as different groups in society, and most importantly, as a single binational community struggling for our common water resources. Historically, those of us that have lived, worked, and thrived at the border region have learned that water resources are an important asset for both our countries. That is one of the reasons why we are all here today discussing the different water issues that we believe are important for our common border region. However, the main challenge for all of us is that at the border region, we are competing for future availability and economic development based on a growing and competing demand for the resource. The region is growing both in urban development and in population, and in the case of Ciudad Juárez, the city is spreading horizontally, which brings a bigger challenge to put infrastructure to provide water in an efficient way. Additionally, water agencies in Mexico must comply with international agreements regarding water rights. Consequently, Mexican water law specifies that people are the first in line for water delivery. So the question in here is if precipitation, as Dave has showed us in his presentation, is decreasing at the Paso del Norte watershed, and the average regional temperatures are increasing, and with our annual population growth of 4.5%, we are already 1.3 million people in Ciudad Juárez. How are we going to provide our communities to the required future water demands at the Paso del Norte region? This is a challenge for the transboundary region where cities are complex on their urban design. It is a fact that limited water resources must provide for different uses: domestic, industrial, environmental, and water for the always relevant and controversial for the region, irrigation for agricultural demands. Nevertheless, the challenge does not rely only on the distribution and availability part. We must also solve the interinstitutional vulnerability issue. Interinstitutional vulnerability is discussed in here as the lack of communication in between different water agencies, both within our own countries and between our nations. Additionally, the lack of academic connection with the world's reality and the limited official funding for characterization, monitoring, and real-time modeling of groundwater dynamics generates a vulnerability for a sustainable transboundary aquifer management. Furthermore, in Mexico, different water agencies have different agendas and visions regarding water management, since all of them are responding to different users at different administration levels. Hence, it is possible that each water agency has their own inside agendas, rules for managing water resources. Regardless of the national water law in Mexico, which regulates and defines national strategies for managing water resources, its applications and efficiency is questionable. In Mexico, all water users, groundwater, surface water, and treated water needs a special permit identified as the water right linked to a certain estimated volume of water, which is registered at the Public Registration Water Rights. However, these permits are limited by a defined volume, which is, in case of groundwater, the numbers are not definitive, since most of the official reports of groundwater availability are changing as the National Water Commission, CNA, brings up to date their studies and more information becomes available and groundwater monitoring techniques are applied to the different watersheds. This challenge of having the right and complete characterization so we can estimate volumes of different aquifer formations is still an agenda to resolve. Furthermore, policies for groundwater extractions are given by the official estimates which are incomplete or with technical deficiencies, which reduces the goal of a sustainable groundwater management and with a high possibility to estimate groundwater potentials of aquifer formation, or even worse, to overestimate availability. One of the case studies which reflects the previous statement is that the Cuauhtemoc Aquifer, located at Central Chihuahua, one of the most important agricultural regions in Chihuahua, leader in apple and corn productions in Mexico, is under severe stress, groundwater stress due to overpumping and bad aquifer management. In 2013, the National Water Commission, CNA, published an official document where they estimated a groundwater budget of deficit of minus 43.4 million of cubic meters for that specific year, which demonstrated a severe stress to groundwater availability. However, in 2015, 2 years later, after that report came in, they recalculated and addressed new studies in which they officially recognized a severe deficit on the aquifer with a total estimated volume of minus 193 million cubic meters. The huge difference on the volume budget deficit within a 2-year time frame was obviously an underestimated calculation that brings uncertainty. Furthermore, the importance of recognizing these uncertainties is because some of these studies are used as official references to endorse policy of groundwater pumping or to promote or withdraw new developments of groundwater infrastructure. This brings me to the main point of my presentation. Some of the tough questions to address soon to promote a potential transboundary aquifer management at the Paso del Norte region are the following. How can we reach a transboundary aquifer management at the Paso del Norte with uncertainties such as the accurate groundwater volume estimates? Even though we have interesting and very important binational efforts, such as the Transboundary Aquifer Assessment Program, or the binational groundwater modeling that colleagues like Ed Archuleta, Bill Hutchinson, Camela Thier, Oscar Ibanez, Rene Franco, Manuel Herrera, Shuping Chen, my mentors, John Hawley and Dr. Saurabh Samani, and the late Artie Mitchelson and Mark Creel did for the region, as many other workers have accomplished these type of works. Is Mexico, the question in here is Mexico ready to sit on an international diplomatic roundtable and discuss the possibilities to reach an agreement on how to manage this important binational groundwater resource? Since natural groundwater flows at this region runs from north to south in some areas into Mexico, is it this a good time to sit and negotiate a groundwater pumping strategy? Or should we keep endorsing the biggest pump wins policy as an ongoing strategy for both countries? I do not have a clear answer for all of these questions, but I think that they are all still on the binational agenda. Over the last 30 years, I have been working on a binational groundwater resource, and at the time when I began as a grad student learning about this issue, transboundary groundwater management was a hot topic. And guess what? It is still a hot topic. I just wish we do not have to wait another 30 years for an holistic solution to these challenges. Thank you for your attention.
Thank you, Dr. Granados Olivas. Our next presenter is Jacob Peterson Perlman. Jacob has a PhD in geography from Morgan State, a BS in meteorology from University of Montana, and he did a postdoc fellowship in water and society and